good evening. Today we are going to a new topic known as formula and variation, which is a Form 3 topic. Our subtopic will be partial variation. I've written an example which will enable us learn on how to deal with questions on partial variations. There are some of the things that we need to understand. Under partial variations before we start doing this question. One of the things is the statements involved in partial variation. Statements involved in partial variations or partial variation. One, you will see this kind of a statement. Part 3 constant and part 3 varies as. So when you see a question having this kind of a statement, part 3 constant and part 3 varies as, then that means your equation will be in the form, your equation will be in the form y is equals to mx plus c. That's what it means. The part 3 constant statement will give you the constant c. So it means you will come up with a constant with no variable. The other statement, part 3 varies as. That means you will come up with another constant which will be the variable indicated after the word as. Now which will be in the form of mx. So when you combine, the whole statement will give you an equation in the form of y is equal to mx plus c. That's when there is this statement. Part 3 constant and part 3 varies as. So the equation you obtain, your equation will be in the form y is equal to mx plus c. We have two common statements which we need to understand. The second one will be part 3 varies as and part 3. So there's something here I've forgotten. Part 3 varies as and part 3 varies as. So you will see that this statement of part 3 varies repeating itself. So for example, you can be told that x is part 3 varies as a quantity y and part 3 varies as a quantity z. So in that case, you will obtain an equation in the form, your equation will be in the form y is equals to mx plus cy, or we can think of z, where m and c are constants. So if you are told that a certain quantity is part 3 as a certain quantity and part 3 as the other one, part 3 varies and part 3 varies, will give you the equation in the form of y is equal to mx plus cz, whereby m and c they are constants. As you can be able to see, in this case, we have two constants, and each constant as a variable. But when you compare the first case of party constant and party varies as, we have two constants. One constant is having a variable, the other constant does not have a variable. So that's the difference. If you can be able to differentiate the two statements in any given exam, then you can be able to do any question from partial operation without any difficulties. I want us to go back to our example. So you will see me saying solution to our exam. Can we be able to see the one of the two statements that we have written here? Yes. You can see part 3 constant, part 3 varies. As long as you see the word part 3 constant, that tells you the equation we will obtain will be in the form y is equal to mx plus c. Now let's do it together. A quantity s is part 3 constant. So you will start by saying s is equals to a certain constant k. This part 3 constant is the constant we are talking about here, let it be k. And it is this constant that is not going to have a variable. And part 3 varies inversely as a quantity t. So you will now say plus a certain constant, you can even say x times the inverse of t times the inverse of t. So this will give us x is equals to k plus x times 1 is x over t. So this is the correct mathematical equation representing this statement up to this given point. Now we can continue by trying to see what the question wants us to do. Given that s is 10 when t is 1.5, s is 10 when t is 1.5. So that gives us the first equation, and we can decide to say over 1, then we look for the LCM. LCM of 1 and 1.5 is 1.5. So we will say 1.5. 1 comes 1.5 times. So 1.5 times 10, it gives us 15. 1 goes to 1.5 times. 1.5 times 10, 1.5 k. 1.5 goes to 1.5, 1 times x. Since this is an equation, we now denote the LCM. So our first equation will be 15 is equal to 1.5 k plus x. So you can say that's your first equation. Now let's go back and continue with our statement. When s is 20, t is 1.25. S is 20, t is 1.25. So we can now write this as 20 is equals to k plus x over 1.25. We can say over 1 over 1. Our LCM 1.25. 1 goes to 1.25, 1.25 times. So times 20 times 1.25, we get 25. Is equals to 1 goes to 1.25 times, then times k is 1.25k. 1.25 goes to 1.25 1 times. 1 times x gives us x. We denote x in because that is the equation. So our second equation now becomes 1.25k plus x. This is our second equation. We can now bring our first equation, which is 15 is equals to 1.5k then plus x as our first equation. We can now use elimination method to solve these two linear equations. We can subtract, since the coefficient of x here is 1, the coefficient of x down here is 1. So when we subtract, x minus x becomes 0. 1.25 1.25 minus 1.5 gives us minus 0.25. When you subtract this, we get 10. Now, this is 10 is equal to minus 0.25. We divide by, remember this is K, so we divide by minus 0.5 on both sides, 0.25 minus. So our K becomes 10 divided by minus 0.25, which gives us minus 40. So that's our part of K. So how do we obtain X? We can use any particular equation here. I prefer as using the second one. We will say 1, that's 15, is equal to 1.5 times K, which is now minus 40, then plus X. This is 15 is equal to 1.5 times minus 40, it is giving me minus 60, then plus X. We take minus 60 to the other side, it becomes positive in this case. So that is what gives us X. 15 plus 60 gives us 75. So that's what we obtain as X. So we must find the equation connecting S and T. Remember, this is our equation. Now that we have found K and X, we now remove K and X, we put the constants, or we put their values. The equation will be S is equals to K is minus 40, then plus X is 75 over T. So that's now the equation connecting S and T. The equation wants us to find S when T is 0.5. Now, we will go to our equation, which is now S is equal to minus 40 plus 75 divided by T, because T now is 0.5. That's what we put down there. So our S becomes minus 40 plus, we take, I think that will give us 150. Because 75 divided by 0.5 is 150. Then our S becomes, this is the same as 150 minus 40. So which gives us 110. So that's how we solve this particular question under partial variation. This is our lesson 1. I will take you to lesson number 2 next time, and we will look at the question which is having this statement, partifiers and partifiers. Thank you for listening to me. God bless you. See you next time.